Okay, moving right along, problem 5 asks us to write each of the following vectors in unit vector notation. Okay, so this is again probably just, this should be just review at this point. But adding vectors or dealing with vectors this way and being able to convert from one format to another is an important thing to know how to do. So again, these did have vector hats on them, but you know, the stupid resizing algorithm in Microsoft Paint does this. So A has a magnitude of 5 and it points at an angle 35 degrees, and it's opening up, this angle is opening up from the x-axis toward the y-axis. So the magnitude is 5, so first of all, both the 5 times something times I hat and 5 times something in the j hat direction. Okay, so the rule is, and this is really just something to remember, that whichever angle you are starting from, or sorry, whichever axis your angle starts from, gets the cosine. So in this case, 5 cosine 35 degrees in the I hat direction. And then the other one gets the sine. So sine 35 degrees, 5 sine 35 degrees, j hat. The last thing to do is get the sines, and by that I mean SIGN, the pluses minus correctly. We are going in the positive x direction and the positive y direction, and these angles are all smaller than 90, so these are both positive. What's important for doing the positive and negative signs is that it is the angles that are being, sorry, not the angles, excuse me. What's important for the positive and negative signs are the axes that are being used as references. So we're starting from starting from positive x and going toward positive y. That makes these positive. I'll show you in the next example why the angles or the axes you're using are what matters. Or sorry, the axes that the angle is referring to is what matters. So for B, B has a magnitude of 4. Okay, so we're good so far. And there's going to be 4 times something in I hat and 4 times something in j hat. Okay, so B starts from the positive x-axis, right? So x gets the cosine of 140 degrees, and it's opening up toward the negative y-axis. So the other one is sine, of course, sine 140 degrees. Okay, now the axes we're using, we are opening from the positive x-axis, so our x component is positive. Let me see if I can do a little better of a positive sign there. Our x component is positive. Nope, that's no better. Well, anyway. And then our y component, now what's tricky here is we are opening up toward the negative y axis. So our y component is going to be negative. Now, actually, what's also tricky here is, let me just write this a little bigger, positive 4 cosine 140 degrees I hat minus 4 sine 140 degrees j hat. Now you might be saying, well, but B points in the negative x direction. Shouldn't this term be negative? And I say, yes, it is, but cosine 140 degrees is already negative. So that takes care of your negative right there. Don't let the fact that this angle is bigger than 90 degrees fool you into changing the sign here. What matters is the angle, or sorry, what matters is the axis you are starting from and the axis you are opening up towards. Okay, and we started from positive x. We went 140 degrees, that's why the sign on this flips when cosine flips, but we don't actually change the sign ourselves. Okay, last one, and this is something a lot of you guys, I see a number of students having trouble with this. This one has an angle opening up from positive y. Okay, so C is 6 times something in I hat, and then 6 times something in j hat. Okay, so we are starting from the positive y-axis. That means that y gets the cosine. Cosine 30 degrees. Okay, and x gets the sine because x is the other one. Okay, now we're opening up toward the negative x-axis, so we got a negative on x and we got a positive on y. That's our answer. Now you might be saying, well, couldn't I just as easily say, you know, 6 cosines, or 6 cosine 60, or negative 6 cosine 60. Let's see, so cosine 60 degrees, I hat, and then plus 6 sine 60 degrees, j hat. You could. I'd encourage you, though, to get used to doing it this way, because it'll be far more useful in a practical sense as we go forward in physics, and frankly, in anything else you're going to use angles for. Okay, and problem 6 coming up. That'll be the last one.